Okay, everybody, this is chapter 4, section 4. This is using a theorem that kind of wraps up everything that we've learned up to this point with side, 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 angle, side, angle, and angle, angle, side. Okay, so we've got to have these kind of down. Give you a little cheat sheet for a second here. Okay, but I'm going to, we have to do some proofs here, a couple in a row here to kind of get a feel for this, but I'm going to still kind of do what we've done with proofs, that one of these four here are going to be my last step, but then I need to go one step further after I get done. Okay, because what we're going to do now is when you prove that triangles are congruent by one of these four things, you're really just talking about some very specific parts of a particular triangle is congruent to another triangle. Okay, like let me just use SAS. I needed two sides and one angle, and the angles between the two sides from one triangle, and it had to be congruent to the corresponding pieces of a second triangle. That proved the triangles were congruent, okay? But in side, angle, side, I still have two angles and one other side from each triangle that I did nothing with. But because now the triangles are congruent, I can say all the pieces are going to be congruent. All right, so it's a shortcut way of being able to do that. So what we're going to do now is, once I've proven a triangle is congruent, they're going to ask me to say, hey, is this angle now equal to this angle? And I can say yes. And I'm going to be using C, P, C, T, C. Okay, that's an abbreviation for congruent parts of congruent triangles are congruent. And that's going to be my last step when I do a proof now. And one of these four is going to be my next to last step. Okay, so we're going to try to do this. So if you guys can go ahead and write down your given and what you got to prove, draw this figure for me, please, that we got. Make sure you label it all up. If you want to hit pause, you can, and then once you get it done, you can go ahead and come back. Also, we're going to prove it, so we're going to draw a two-column proof. Okay? So if you could do that. Okay, so what we're trying to prove here is that triangle DCE is congruent to triangle DCE. So I'm going to do something here. I'm trying to prove, let me use a different color here. I'm going to try to prove that this triangle right here is going to be congruent to this triangle right here. Okay? And the authors of these were really nice. They said, hint, prove that triangle ABC is congruent to triangle ADC. So if you looked at that, I pulled them out. The bigger triangles, ABC and ADC, I kind of pulled them apart so we can kind of see this, okay? All right, so they're telling us, giving us a clue, prove that the two gold triangles are congruent first. And are these ones that I colored in green, are they parts of the bigger triangles? And they are. Okay, so if I can prove the two big triangles are congruent first, then I can say the smaller ones are. Okay, so what was given to me, that angle 1 was congruent to angle 2. So I'm going to draw that on the gold triangle. So I've got to cover it up. That's 2. Yeah. So angle 1 is congruent to angle 2. All right. Angle 3 is equal to angle 4. 4, 3. Okay. Ah, dang it. Hold on. Screw myself up. Forwards and backwards. Okay, there we go. So show that on my picture. If you want to, we could show it here too. Okay. And now it's not a whole lot there, and let's write it down too. Angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4, and that was given to us. What else can I prove then that are going to be congruent in the gold ones? You know, that I pulled it apart, but remember when you pull it apart, were there pieces that were congruent to each other? Well, yeah. CA was that line. Remember, if you have a figure, and I pulled it apart, but if you have a figure and it's being cut, in this case that way, are those sides congruent? They are. So we're going to come over here, we're going to go AC is congruent to AC. Remember our good buddy, the reflexive property. So now I can say that these two sides are equal. Okay, now looking at the two gold triangles, is there a way I can prove that those two pieces are congruent to each other? Or, and I'm sorry, we already did, because by reflection, can I prove that triangles are congruent to each other? And you can. Well, let's watch this. We got an angle, a side, and an angle is congruent to an angle, a side, and an angle. So I'm taking their hint. They gave me a hint. Do that first. So I did prove that angle, triangle ABC is congruent to triangle ADC, and that was by angle, side, angle. Two angles are congruent, and the included side were congruent from each triangle. Okay? And I go back, they're really trying to get me to prove that these two triangles were equal, and are the two smaller triangles part of the bigger triangles, the gold ones? And if I pull them back, are they? And I hope that you agree with me that they are. Okay? So now what I can say is, since I proved that triangles were congruent, and the smaller ones were pieces of the bigger ones, I proved that triangle DCE was congruent to triangle DCE by congruent parts of congruent triangles are congruent. Last step. Next to last step. And man, if I've got the ending in order, you know, this one right here, that's kind of your wild card, because you don't know which one that's going to be, but you know it's going to be one of those four in the next to last step, and you know that this one's the last step. There's not a whole lot more for me to have to probably do. Now, to be honest too, we've had a bunch of proofs here that have kind of been 4 steps. Sometimes we need to go maybe 5 or 6 steps, but you know, that's just you kind of getting used to this and understanding what you know, what you see, put it down. Okay. All right. So let's go down here and let's do this. Write down the given, write down or draw the picture, and then we kind of started this proof off for us a little bit, so we'll go ahead and just kind of fill in what's blank. So this one might be a little easier start for us to get going here, okay? So if you want to hit pause and then come on back, and then we'll go over the solutions to this one. Okay. Okay. So really quick here, you know, they give us some nice things. They didn't really draw on the picture. I'm going to draw it on the picture, okay? So angle B is going to be congruent to angle D. All right, and then C bisects line AE. So this is another one that kind of shows up too. This middle vertex here, angle C, it bisects the line AE in this case. So remember what bisect means. It cuts something into equal halves. So bisect is a word that we learned back, I believe, chapter 1, pretty early on too. And we got it kind of shows up a lot more now as we kind of move forward. So bisect cuts into equal halves, show it. Okay. So that's what is given, but I showed it. Why is AC equal to EC? Even though I showed it, I got to give a reason. Well, it got bisected, so if it gets bisected, it's just the definition of a bisector. C was the bisector, okay? If something bisects it, I can say that the pieces are equal to each other now. So this is another one that kind of shows up a lot for us, and we can use it pretty easily in a theorem or in a proof, okay? Why are angles 1 and angles 2 equal, okay, in step 3? Well, this is a bow tie. We go back to last section. I wrote out a bunch of keys for you. When you see a bow tie, you think vertical angles. So the angles are going to be equal there. So vertical angles. Okay, that's just, man, that's just something that you've got to jump out to you, right? Right when I saw that, even before I did anything else, I go, hey, I got vertical angles here, okay? Now, why are triangles ABC and triangles EDC congruent here? Okay. Well, look at what I got. I've got an angle here and an angle here, congruent to an angle here and an angle there, and then I've got this side is congruent to this side, and you know, you've got to just have this stuff down. It's the only thing we've been doing. Which one of these 4 is it? Well, sides are not included, so it's got to be angle, side. Okay. That was, and then, oh, there's another step down here. What they really wanted me to prove are the 2 angles are equal. So this is a really good example of where this CPCTC comes in. Okay. I proved that the ABC was congruent to EDC. I just proved these 2 triangles are congruent because these 3 parts that I had was a theorem that we learned, and but what that really just says is everything in the triangles are going to be equal. I just have to go to all 6 pieces basically. So once I've proved the triangles are equal by one of these 4, I can now say that every single little part is going to be congruent. In this case, they want me to prove those angles are equal, and I can just say congruent parts of congruent triangles are congruent. Okay, so can I do this last? Proof that one of these 4 is the next to last step, and I'm always using CPCTC as the last step. Okay, have that down. Makes this stuff so much easier. Okay, and hopefully they become easier as we kind of go along. Okay, so that was 4.4, pretty short, pretty hopefully easy, but this one really takes a lot more work. So make sure that the classwork gets done, the homework gets done. And then when you're in the homework and stuff, let's make sure you're asking for questions too. All right, because the notes were pretty quick here, not a lot of depth, and you need to really practice this a lot. Okay, all right. Get a hold of me if you need me. Make sure you get the classwork done.